So let's continue with our next question. It is trigonometry. Let's go see what this question was about. Right. So it says that in the diagram below, AD is a vertical structure. All right. There's a vertical structure there. We don't know what it is. Allow me to just wing this one and say this is actually a building. Maybe it's probably a building. I don't know what it is. Right. Let's just see. Maybe that was a building. Right. You can see this is just to help you to understand what is going on here. So that's the vertical structure we are dealing with there. B, C, and D are 3 points in the same horizontal plane. The angle of elevation, remember, the angle of elevation is looking up. The one of depression is looking down. So the angle of elevation, which is the angle when you're looking up, of A from C is theta. There it is at the bottom. This is the angle of elevation. And then we are told here that we need to now, BC equals to K meters. There's BC equals to K meters. And then now here's one part that is not on the drawing but is appearing in the love letter, which tells you why it's important for you to read the love letter. Apparently AB is 2 times BC. And if BC is K, that means this one is simply going to be 2 times K. Very important for you to keep that in mind. So this emphasizes the importance of reading the love letter. That part was not in the drawing. If you don't read that, you're going to miss on crucial information that could help you to find the solution to the question. So angle ABC is 2 theta. Angle ABC is 2 theta. We can see that we're happy with what is going on here, right? So now the question says to us that we need to prove that AC is equal to K multiplied by the square root of 1 plus 8 sine squared theta. So like I said, I don't care what the right hand side looks like. All I know is these people are asking me to calculate AC. So what I'm going to simply go and do is look in my drawing and try to locate this AC that they're talking about. So if you check there, you will see that AC is this line here. It's this particular part here, right? And that happens to be a member of this triangle that you're looking at here. If these triangles start looking too much for you, just isolate them and try working with them separately. You'll see what is going on there. Very, very powerful indeed. Right, so let me write that. I've got this and I've got that, right? I've got 2K here, I've got K here, and I was told that the angle between those two sides is simply equal to 2 theta, and they're asking me to find AC, right? This is C and that one is A there. So the only rule that you can use when you've got two sides and the included angle is a cosine rule to work out the third side of that particular triangle. So let's do that quickly. This is actually going to be AC squared is one side squared, which is K squared, plus the other side squared, which is 2K squared minus 2 times K times 2K multiplied by the cosine of the included angle, which is 2 theta. If you simplify this, you'll be having K squared, and this one is going to be 4K squared here. So that's simply going to be 5K squared minus 4K squared cosine of 2 theta. And then if you simplify here, you will notice that we just want to find whatever the AC length is in terms of theta. So this is going to be 5K squared minus 4K squared into 1 minus 2 sine squared theta. This is the double angle of cosine. We expanded it in that format. And then you will see that you'll have 5K squared minus, if you go in here, you'll get 4K squared, and if you go in there, you'll get plus 8K squared sine squared theta. This is simply K squared plus 8K squared sine squared theta. K squared is a common factor. You take it out, you're simply going to have K squared into 1 plus 8 sine squared theta. And if you take the square root of this to find the length of AC, you end up with the square root of all that, because if AC squared is what you have and you take out the square root, you'll get K times the square root of 1 plus 8 sine squared theta. Right, very powerful indeed. Thank you very much.